All right, in unit workbook 5, we are going to be talking about rates and unit rates. And so there's some new vocabulary words today. The first word we're going to talk about is a rate. If you remember what a ratio is just a comparison of two numbers. Well, a rate is actually a very special type of ratio. So when we talk about ratios, some ratios are rates. What rates do is it still compares two quantities. So that sounds like what a ratio is. The only difference is it must have different units, and it also expresses a multiplicative relationship, which so do ratios. So I always talk about how many times bigger one is than the other. So when they talk about different units, they're giving us some examples here. 4 pencils, $2. Those are two different units, pencils compared to dollars. Here it's 300 miles and 5 hours. So we're comparing miles to hours. And the last one is there's money, so $3.07 to 16 ounces. So all those are comparing different units, and that's why they're a rate. But when we talk about unit rate is huge. I use unit rate almost every time I go to the grocery store. Unit rate is going to look at the comparison, look at the relationship, but you're always comparing something to one unit of another quantity. For example, if you say you get 6 miles per gallon, that means you go 6 miles in 1 gallon. So you're comparing something to how many miles you can get off 1 gallon. Or if you say, hey, I make $6.50 an hour, you're getting $6.50 in 1 hour. So it's always comparing it to one. 8 chairs for one table, 2 cans of water for every can of orange juice. All those are called unit rates simply because we're comparing to the number 1. And then the last word should be very obvious. Equivalent rate is basically two rates that are equal. Remember how we did two ratios? If we said if they have the same value, they're equal. Well, two rates are going to be equal if they have the same unit rate. So when you're asked to compare rates, all you do is have to find the unit rate. If they're the same, you know they're going to be equal. Okay, the review problem is Julie and Leo are partners on a science project. The ratio of number of hours Julie spent on the project to the number of hours Leo spent on the project was 4 to 5. If Leo put in 25 hours on the project, how many hours did Julie spend on the project? So remember how our first thing is always underline the ratio statement? Right here's the ratio statement. The ratio of the number of hours Julie spent on the project to the number of hours Leo spent on the project was 4 to 5. So that's my ratio statement. Right in that statement, it gives me the ratio of 4 to 5. So that's going to go in my circle. I do not go on until I label what's 4, what's 5. How I figure that out is I read the sentence. It says the number of hours Julie spent to the number of hours Leo spent. So Julie's first, so she's got to be the 4. Leo's second, so he's got to be the 5. And then now that I have those labels, I know those labels get moved right over here because they have to be the same on both sides. All right, and now we're just going to go, what do I need to know? I need to know Julie's hours. Right here it asks me, how much did Julie spend? Right where the Julie is, I'm going to put my big old X. Okay, and the only other number I have is Leo put in 25 hours. Well, that's really good because the bottom is labeled Leo. So Leo put in 25 hours. To find that missing X, you certainly can multiply the two diagonal numbers right here if you want, and then divide by 5. Or I'm just going to look at the bottom. I can see I'm getting 5 times bigger, so my top has to get 5 times bigger, which means it's 20. And that should make sense that Julie put in 20 hours when Leo put in 25, because we know that Julie is less than Leo. All right, now we're going to start talking about unit rates. Example 1 says the automatic car wash can wash 3 cars in 6 minutes. What are the two quantities compared in this example? We could say this one of two ways. So you see that it says 3 cars in 6 minutes. So you could say 3 cars, 6 minutes. Great, you just compared them. You wrote a ratio. It's also a rate because those labels are different. But you could turn that around. You could also say, hey, in 6 minutes, you wash 3 cars. So you could compare them that way also. It all depends on what you're looking for. So now the next question is find the unit rate, meaning compare that number to 1, or in other words, make that bottom number 1. Finding the unit rate and finding the value of a ratio is exactly the same thing. So what you're going to do is you're going to take the top number here, 3, and you're going to divide by the bottom number, 6, okay? So it's always top divided by bottom, because what that does, if you think about it, if we divide the top and bottom by 6, well, 6 divided by 6 is 1. I just changed my bottom number to 1. So basically, if you just take 3 divided by 6, you're going to get 0.5 on your calculator. And we know the bottom's number is 1. We're changing the bottom number to 1 because we're taking the top and bottom and dividing by 6. This one over here is much easier to do. Top divided by bottom, that would be 6 divided by 3 is 2. Okay, now we got to be really careful. These are totally different unit rates. So that means these rates are very different, correct? But we got to be careful what we're talking about. What does this mean? Well, if you go back up here, this says 3 cars, 6 minutes. So when I read this, this is saying a half of a car in 1 minute. So if I want to know how many cars you can do in a minute, I would use this. So I'd say half a car in 1 minute. But this one is minutes, 2 cars. So this would be 2 minutes, 1 car. If I asked you, how long does it take you to do a car? This would be the unit rate I'd want to use. It's 2 minutes per car. You can see the difference. So you got to really be careful with your labels and how you read them. All right, in example 2, it says Nanette and Rachel each made juice by mixing water and concentrate. Use the information in the picture to determine which juice mixture is stronger or more concentrated, meaning less water. Nanette's or Rachel's? Or is the concentrate the same? And why do you think so? So what we're going to do is we're just going to look at the comparison here. And you can see up in our key, a white glass is water and a black dark shaded one is concentrate. So if you look at this, you could say on this one, there's 3 concentrate to 5 water. Okay, and this one, if you counted the concentrate, this one on Rachel's, you'd have 3, 4, 5, 6, 7 concentrates to 1, 2, 3, 4, 5, 6, 7, 8, 9 waters. Okay. And then if I went, well, I want to check to see which one is actually more concentrated, which one has more concentration in it. What you're going to want to always do is find the unit rate, because I could compare these. We've compared these before with doing other ways, but if we also just got used to finding the value or the unit rate, it's a really easy comparison. So we're going to start using our calculator a little bit more in this lesson. So what you need to do is take your calculator and just take 3 and divide by 5, and your answer is 0.6. So you have 0.6 concentrate per 1 water. Because whenever you take the top divided by the bottom, you're really getting rid of that bottom number and having it be 1. So 6/10 concentrate per water, 1 thing of water. This one, if you take 7 divided by 9, your calculator is going to be 0.7 repeating. So it's 0.7 concentrate for 1 water. So you should be able to see which one is more concentrated. This one has more concentrate for 1 water versus this one. So Rachel's is more concentrated than Nanette's. Okay, in example 3, it says Juanita drove her car 120 miles in 2 hours. Carlos drove 180 miles in 3 hours. Who drove faster, or did they drive the same average speed? Same average speed. So when you talk to someone about speed of a car, like how far do you drive or how fast do you drive, well, the law says we can drive 55 miles per hour. You've seen those signs before. What that means is you can go 55 miles in 1 hour. Anytime you see that word per, it does mean 1. So that right there, whenever you see your mile per hour sign, that is your unit rate. If I look at the question, I look at Juanita, it doesn't tell me how fast she's driving per hour. It does tell me, though, she drives 120 miles in 2 hours. So that is what she's doing. Then if I go over to Carlos, Carlos is driving 180 miles in 3 hours. And we are supposed to figure out who's faster. Well, if we're going to compare these, we can compare these a couple different ways, but remember the easiest way to compare rates is to change it to the unit rate. That's what I do when I'm shopping. If something comes in an 8-ounce bottle or a 12-ounce bottle, I'll change it to 1 ounce, change everything to the 1, and then I can compare. So basically, to find unit rate, we're just going to take the top and divide by the bottom. So 120 divided by 2 is 60. So the label on this, be very careful, it's 60 miles per hour. This slash, when you make that, does mean per. Otherwise, if you want to be safe, you can always put 1 hour on the bottom. We're going to do the same thing for Carlos this time. So it's just basically the top, and we're going to divide that by the bottom. So 180 divided by 3 is again 60 miles slash per hour. And so now they're saying who drove faster? Neither one. They both drove 60 miles an hour. So they were driving the same. You wouldn't be able to tell that by looking at just the 120 over 2 and 180 over 3. Okay, example 4. This is really where I use unit rate in my real life all the time. It says, use the information in the table to determine which jelly is the better buy. Are there any two varieties of jelly that are the same? And if yes, why do you think so? So we have a table that talks about the strawberry jelly. And this jar, the top jar of Smucker's, is 12 ounces, and it costs $2.16. Welch's is 20 ounces, costs $2.99. Smucker's is 32 ounces, is $2.56. And Welch's 28 ounces is $2.24. Well, if you asked a young child maybe and you said, which one is the cheapest? Sometimes they would just immediately say this one. It's cheaper. It's $2.16. And as hopefully you realize, you can't just go by that. Yes, it is a cheaper jar to buy, but can you also see it has the least amount of jelly in it? So we can't just make that judgment right away that the cheaper is going to be the better. We also can't do the opposite. And some people don't realize that. Some people think, oh, the bigger the better. So if it's bigger, it's automatically going to be cheaper. Often I'll go into Walmart and I'll be doing unit rates. And sometimes the smaller bottle is cheaper. Like I could buy 2 bottles of the smaller bottle, and that is cheaper than one of the big. So be really careful when you do your unit rate. Unit rate is very simple to do. If you think about what unit rate means, unit rate is talking about money per something. It's either how much money per banana, how much money per box. Most of the time, this is money per ounce. So they're going to weigh it, and then you're going to find out how much money for 1 ounce. You can see here your price right now, if I wrote that, is $2.16 for 12 ounces. And I want to change my bottom number to a 1. So that's basically just finding the value, finding the unit rate. So if you just take your calculator and take $2.16 and divide by 12, you get 18 cents. You get 18 cents per ounce. So you would label it like that. So you'd spend 18 cents for every ounce. And then we're going to do the same thing with Welch's. So, if you want to really start getting good and fast at this, if you look at what you're trying to find right here, I'm finding money over ounces. So I'm always going to take the money and I'm going to divide by the ounces. That's the order I do it. So if I grab my calculator and type in $2.99, so go ahead and type that in, $2.99, you're going to divide by 20. And that answer doesn't even look like money. It's 0.1495. Okay, and we know that's how much it is per ounce. Now, in a grocery store, if you go to Walmart and they have unit price figured out for you, they will go to the third spot of the decimal. So what they would do here is, actually this is a little confusing with this number, they would look at the 9 and they would say the number to the right is high, 5's high, so the 9's going to go to a 10, and then this is going to round to a 5. And then this fourth number just gets erased, just gone. So I should have probably just erased this. okay? So that's what they're going to do. They're always going to round to the thousands place. Many kids will think, oh, that's 150 cents. But in reality, all it is 15 cents. And if there was something there, there'd be a little more. Kind of like in the gas stations. Have you ever noticed at the gas station, like right now, it's $1.99.9, and there's a little tiny 9 up there. So you're paying $1.99 and another 9/1000th of a dollar. And so that kind of adds up if you buy that over and over again. Okay, let's take a look at Smuckers. So Smuckers, I want money divided by ounces. So I'm going to type $2.56. I'm going to divide by 32. And that is 0.08. That comes out nice money right away. So it's 8 cents per ounce. And finally, I'm going to go ahead and do the 224. So 2.24 divide by 28. And that is also 0.8 cents per ounce. All right, so the question is, we have to find which is the better buy, and are any of these the same? So you should be able to see that Smuckers and Welch's are the same, and they are the best buy, aren't they? This is 18 cents for an ounce, 15 cents for an ounce, and these last two are only 8 cents for an ounce. So it wouldn't matter whichever one you would buy, you're paying the same price per ounce of Smuckers or Welch's. So in that case, buy what you like the best. And I do want to, one more thing, I want to point out that let's say you're doing something like, I'm going to make just a problem up. I'm going to say it was $2.35 for 3 pounds. And I said, how much per pound? Well, I'm asking you how much money per pound. So the money goes in first. So it's basically 2.35 divided by 3. My answer on my calculator when I do that is 0.78333333 forever, okay? How you're going to write that is you're only going to go to the third spot past the decimal. So you'd write 0.78, and then you just look. Should this 3 stay a 3 or go up? And the reason it should stay a 3 is because the number on the right is low. So it's going to just stay a 3. Okay. Now when I say how much money is that, you're not going to say 783 cents, I hope. Okay? You can see it's 78 cents and a little more. Okay? The 3 just means there's just a little bit more than 78 cents. It is not 783 cents. When we want to read cents, it's only 2 numbers past the decimal. So I would say this is 78 cents per pound. Okay? The only reason we'd ever use that third number is if I was buying another object, and let's say that was 0.788 cents per pound. Well, this is 78 cents also, and a little bit more. So actually see how the 8 is bigger? So this one with the 3 is actually the better buy.